I got stuff for you.
Holy moly. I need to get some snakes and release them around my house.
But they love eating people. They love eating kids.
These guys are the scientists of the supernatural, lecturers leaving lessons for inquiring laymen. They are applying the scientific method to a world that baffles science. They are the cryptids of the corn.
Every day that you open your mouth,
I know, right?
I'm more convinced that you're abducted by aliens.
No.
And it just stood up. I mean, it just like kept going and going. And she goes, what the?
These are idiots.
I was laughing reading this because I already knew how you would feel.
Idiot. What part of the story fits your balloon?
Well,
This isn't a UFO. But who else has big black wings and red eyes?
Batman.
Well, Mothman.
Oh yeah, Mothman.
Well, everyone, I think we know exactly what it is. So say it all with me. It was the sandhill crane.
Would you try it?
No.
You wouldn't eat it?
No.
Why?
Because they're probably toxic. There'd be a lot of poop in my pants. I've seen a 6-foot alligator go swinging through the air and slam into a tree. Welcome back to Cryptids of the Corn podcast. I am the great and powerful mystery.
And I'm J Clone 65.
Me. And I've officially added another title to myself.
Oh,
Author.
that's right.
Never thought, for a man that can't read or write.
You would, yeah. I wouldn't imagine a author being on that list, but here we are.
It's here. No, so be on the lookout. Probably November. Our first book.
What are you calling it?
Well, I'm not going to release the title yet, but it's
Okay.
about organic UFOs. It's the introduction book to our views on the phenomena. It's like the building block. It's a book to use as like a building block.
Yeah, it's a foundation book.
Yeah, and there's
We're laying the bricks.
the second book's like 30% done because I chopped it to in half.
Right.
And then the third book is the one I'm really, really excited for as well.
So it's a trifecta piece?
Yeah, they're coming. I got Talk to Tech software, so it was halfway decent. So it's coming.
Major upgrade.
But keep an eye out for the book. As by the time this comes out, which is the endish of September, you will. I mean, I'll know more then because it's in the editing process right now. It's out of my hands. So by finished, I mean,
Well, you've never made a book before,
yeah,
so we're all learning this together.
yes. And I thank you, Michael, which we'll talk about in a minute, for helping.
Author Michael Thompson.
Winslow Hoffner, Chicken Boy, and the Orb series.
That's right.
I have it written right here in front of me.
Oh.
So I can remember. So welcome to the Badly Explained Physics episode,
Oh, sweet.
because we're going to cover a lot of physics things today. And it will be badly explained.
Oh, by us.
Yes.
Okay, understood.
Yes. No, it'll be badly explained.
That's all right. I'm a good translator.
We're going to have fun with it. No, so reviews. Before we get rocking and rolling, we have 2 new Apple podcast reviews. Now, the thing with Spotify, they changed how it works. So if you comment on an episode, I can now reply to your comment or whatever. But the second I publish your comment, it's gone from my list forever. It's lost to the ages.
The second you publish it.
Yeah, the second I agree that it's a comment that should be public. So I'm having a hard time tracking them. So just take note that most of the time I'm replying to them now.
Okay.
So thank you for your 5-star reviews and your comments and stuff on Spotify.
Yes.
They're just hard for me to chase down for when we do the reviews.
Yeah, Spotify, I don't know why it's so... I don't know why they don't have a review, like, board. I don't know. But from High Lifer 2112, the title is, "The Show is Good." Very refreshing to hear the younger generation thinking for themselves and using their God-given gray material. Yes.
Thank you for the great show, and I highly recommend it for this like-minded people.
Oh, thank you. No, that's what we're all about. Thank you.
Thank you. And from Jeb from Missouri, says, "Not your average soy boys.
There, all right.
Excellent podcast. I use 3 exclamation points to illustrate the illustrious exuberance. I assure you that..." He uses a lot of big words and it makes me laugh. "I assure you, it's a far from a shine. Your show will always have the protuberance in my heart. Always listen to the factual excited of season 6.
I think he specifically wrote this for you to read.
Yes. No, I think there was a joke in there.
Yes, and protuberances is
Protuberance is the only word I knew.
I love that word.
But no, thank you, Jeb from Missouri. Not your average soy boys.
Thank you very, very, very much.
It made me laugh. It was fun.
Yeah, that's great.
New Patreon members real fast. Holly Patrick, welcome. And Jackie Miller, welcome.
Welcome, both of you.
Welcome to the cult.
Yes.
Conferences.
Hope you're enjoying yourself. Conferences.
We have the Ohio Bigfoot Jamboree coming up, the one we're putting on, the one we're running.
From our hometown.
It'll be in a couple weeks after this, when this comes out.
That's right. Ohio Bigfoot Jamboree, October 5th. Our speaker tickets are sold out as up to this point. However, the whole event itself is free to attend. So
there's tons of games and all that. Listen, we'll do a Wednesday episode about it this week. So you'll have all the details. Listen to that. All right. Once again, the T-shirt contest winners. This will be my last shout out for them. But Winslow Michael from the Winslow Hoffner series, Chicken Boy, and the Orb. I'm actually wearing the T-shirt he did for us right now.
Yep.
Check it out. Chris Goings, Black Sheep Studios, Nevermore Hollows podcast. If you need art done, I love Chris's style, but he did the bus logo.
It's a wild ride shirt.
It's a wild ride shirt.
Yep.
And Troy Bursch from Into the Abyss podcast. So check out all these guys and all their amazing works. You ready to get into physics?
I was born ready, like Jack Burton.
I don't know who that is. The observer effect.
All right.
So we're going to talk about the double-slit experiment and the observer effect first.
Right.
Later on, I have some big questions from physics because they're really interesting when we start talking about the physics and the paranormal are the exact same thing.
Yeah.
Some physicists admit it, especially when we start talking about quantum physics.
Well, there's paranormal is just physics or science unexplained.
Yes, 100%. So, I can never say it. Schrodinger's cat. How do you say that?
Schrodinger's.
Thank you.
Schrodinger's cat.
Yes. Is the observer effect that the basic explanation is that the universe is undecided until an observer is witnessing it. Mm-hmm. So with the double slit experiment, it is, I'll read you the textbook definition, and then we'll kind of break it down to the best of my understanding. And for everybody, we're going in this with the best of our understanding. We're not physicists. And physicists don't agree with each other at all. I want to make that very clear when I was researching this episode.
Yeah.
You can find high-level physicists that completely disagree with other high-level physicists, and that's perfectly fine. So nobody understands.
Take all this with a grain of salt. Pink Himalayan salt found in Bigfoot breath.
Which we'll play here in a little bit. Yeah. No, so just so everybody understands that nobody understands at all.
Okay.
In modern physics, the double-slit experiment demonstrates that light and matter can be satisfied in the seemingly incongruous classical definitions for both waves and particles.
Okay.
Does that make sense?
Yeah, I mean,
light
both
and matter can be both different things.
A solid particle and a
wavelength.
Yes. Which,
for anybody that doesn't understand, so energy moves in waves. Mm-hmm. It's just kind of how it moves through the universe and interacts in the universe. And we'll even talk about light speed. I found out some very cool things looking into light speed with this.
Okay.
That nothing in the universe can travel faster than light. But the only thing that doesn't count in that is the universe itself.
Okay.
Isn't that weird? Isn't that a weird statement?
It's a fallacy, it sounds like.
No, it's a misunderstanding of people.
Okay.
That when you say nothing can travel faster than light because it turns into pure energy or whatever.
Okay.
That's inside the universe. They leave off the last end of that sentence.
Oh, I understand. Okay.
The universe itself can move way faster than the speed of light.
Gotcha.
So it's like when you just take a chunk of a quote and you never finish the quote. That's what's happening there.
That never happens in media.
Ever. So it's showing that light behaves both as a particle and as a wave. So the double-slit experiment is the back of the wall, the screen, records all the light that touches it. We'll talk about the observer effect too, mm-hmm. and the arguments about the observer effect is crazy. Mm-hmm. Like this has been this was first done in 1801.
And maybe for anyone that's like can't get the mental image in their head between like being a particle and a wave.
A particle is like the atmosphere is full of particles.
Yeah,
a bunch of imagine dots. This is about the best way. A bunch of marbles.
Mm-hmm.
So marbles generally, without being interacted with, well, if you just with force, will move in straight lines.
Yeah. If you shoot it out of a gun, it's gonna
Straight line. When it hits the atmosphere, it'll start bending and that kind of stuff.
Right.
But generally, light will always move in this wave pattern, the serpentine pattern.
So I imagine
energies.
I imagine throwing a marble into like a lake or a still water, and when it splashes and ripples out, those ripples is that wave. It's moving in a whole.
It's not moving like a particle.
Correct. It's moving in that ripple, that wave.
So the double slit experiment is there's a wall with 2 triangular slits cut into it.
Triangular or just rectangular? Like
rectangular, triangular. It doesn't matter for this.
Well, true.
It's been done literally, we'll talk about it, hundreds of times.
Okay.
Hundreds of times for over 200 years.
Wow. Okay. I didn't know it's been going that long.
1801 was the first time.
Okay.
And so this has been, that was Thomas Young's experiment was the first one to do this. But you cut the slits into this, whether it's cloth or hardwall, doesn't matter. And then now we actually have the screen actually itself records the
on the backside. Yes.
Yes.
Yep.
So when you shine a particle gun, which is essentially a fancy flashlight, either or, doesn't matter. So if you shine a flashlight at this wall with the 2 slits, the back wall, the screen, you imagine there's going to be the 2 cuts, the 2 slits just mirrored backwards.
Right.
Right? Does that make sense?
So yeah, they're shooting.
You're shining a light through 2 holes.
And they're shooting like what's that called? Protons?
Protons, yeah, it's light particles.
Those light waves? Yeah. Okay.
Yes, those light particles are protons.
Okay, just making sure.
Then we didn't know that till this.
Okay.
I think they're weird. So you're shining this flashlight at this 2 slits in a piece of fabric. The wall behind the piece of fabric, opposite of you, will have the 2 slits of light on it.
Right.
That's conventional, right?
Yeah.
We see that. It does that, right? A lot of times it does that. Sometimes it doesn't.
Right.
And it'll do fractal patterns. A lot of times it's just the same squares or whatever shape you had cut into it, mirrored across a single band.
Which the best visual representation I've seen to explain that is, again, like the ripples going through. So imagine the ripples going through the 2 slits rather than a straight line shooting the gun through. It ripples through. So when those ripples get through those slits, it's like another wave coming out of those, and then those bounce off each other, and it's just craziness.
It can be.
Right, it can be.
So up until relatively recently, the observer effect was affecting this. So the observer effect, when we are watching this experiment, it behaves like a particle.
Right.
You just get the 2 main slits, the 2 main images, the 2 main pieces of light going through the fabric,
right,
and putting the images back. Like you at home, you can do this
because
you can do this at home. Roughly, you can have a bed sheet, cut 2 holes in it. If you shine a flashlight through a bed sheet in a dark room, you're just going to get the 2 shapes that you cut into the bed sheet.
Because the way they do the experiment, they like shoot 1 proton through at a time. So the proton basically has to decide if it's going to go through one slit on the left.
It may not even hit the slit.
Right.
It may hit the board and bounce
back off.
Yeah.
Either way, though, it's going to find its way through one slit or the other. So after they do this thousands of times.
Hundreds of thousands, millions of times. I mean, they're shooting
the image on the back is going to reflect one or the other slit.
So when I know you don't like him, and I don't care for him either. Neil deGrasse Tyson.
Right.
Is one of these physicists that argue for the observer effect.
Mm-hmm.
And I believe in the observer effect. Some modern physicists say that it doesn't exist.
Okay.
So like I said, this is controversial stuff inside the physics field.
Right.
Let alone outside when we're talking about it. So when you watch this experiment run, you're watching it. It's behaving how you expect it to behave. The second a conscious observer turns around, that's when the system starts doing whatever it wants. And most of the time, it'll behave like a wave then, not a particle.
Right.
Where it'll have the fractal pattern of the shapes across the whole board.
Mm-hmm.
I've even seen the experiment do completely fractal patterns, like a kaleidoscope of lights.
Oh, yeah.
Behind it. The only reason we know this is because the board is recording what's hitting it.
Right, exactly.
The second that an observer turns around and starts watching again, it starts behaving like it should.
Like a solid
we
again.
Expect it to.
Mm-hmm.
So what this tells you, in some way, and I'm watering this down dramatically for this talk, is that the universe, the light, the universe itself,
Right.
reacts to a conscious observer.
Right.
And follows the conventional laws put forward towards it.
Right. Yep.
The second the conscious observer, not the cameras, not the recording equipment, a human in this aspect, turns around and stops paying attention to the experiment does whatever it wants.
Right.
This has been done thousands of times in hundreds of accredited labs across the planet.
Ain't that nuts?
And it's 99% of the time, it's always the same results.
Okay.
And it's arguing why you get different results. So a modern physicist says that the observer effect doesn't exist because it's actually a weird electronic microscope management system error. Like I said, I'm really going to paraphrase a lot of this stuff.
Yeah.
And that's what's causing the observer effect. That has been removed several times and still does this behavior.
Right. Yep.
So it's argued. You can so people at home, you're going to Google me or whatever, and I highly suggest you do your own research on all this stuff. Everything we ever talk about, do your own research.
For sure.
You're going to find people that are disagreeing with me, and you're going to find people agreeing with me, and both are masters of physics. They have degrees and whatever.
You don't have to describe me that way.
So the observer effect in physics, it's the observer effect is the disturbance of the observing system by the act of observation. Basically, you change an experiment's outcome by watching it.
Right.
This is often a result from, all kinds of instruments that by necessarily alter the state of what are being measured in some sort of manner. The common example is checking the pressure of an automobile tire is the simplest way we can describe this. The way you check it is using a system that lets out some air. So
Right.
the second you check it, you change what's in there. It's never, the reading you get is never the actual reading in the tire.
Okay.
Does that make sense?
Yeah, it does.
When you use the gauge, you're letting air out to
Just
check
a
the
little
pressure.
bit, yeah.
And we're talking
Minuscule.
amounts.
Right, but it's enough.
But when we're talking about physics, that matters.
Right, yeah.
When we're talking about, to the 10th power,
The correct sig fig.
yes,
Significant figure.
it matters. So by acting upon the experiment, by measuring it, we are changing the outcome.
Okay.
Blowing it up to something as fundamental as the double slit experiment, we see that our consciousness, our observation, changes the universe around us. It falls into line with whether it's. I don't know if it's what we expect of it. Nobody knows. None of these physicists know.
Right.
What this could mean is that we talk about in our show all the time, parallel dimensions or extra dimensional things, that they could be around us all the time. There's no curtain. There's no veil. The universe throws that up when we are watching it. So the second that no conscious beings watching it. So when we talk about the double slit experiment, they've done it with animals, right? And certain animals it's seen, and this is more controversial, that even so, have seen to affect the experiment.
But it's not animals change the outcomes.
But not all animals.
Okay.
And not all living things. For example, there's always bacteria in these boxes where these experiments are
True.
running, and they're not changing it.
Right.
The universe is not reacting to bacteria. And in the same way that's reacting to us.
It's because the bacteria don't have consciousness or demons.
But it could be flatworms. I wonder if One knows any of these people that are running this experiment, and he could put one of his flatworms in it to see if it reacts. I'm really curious
I'd like to know.
because they learn. They have maybe not consciousness in the same way we have consciousness,
But they remember.
but they remember things. They learn things.
Yeah.
They can predict how outcomes will happen. So this is where physics turns into quantum mechanics.
Oh, gosh.
And quantum mechanics, most physicists hate it. Because what did Albert Einstein call it?
Spooky action at a distance. Yeah.
Where you can see the outcome, right?
Right.
And it's trying to guess what's causing
All
it.
that in between is spooky.
And this is where the paranormal falls in line, in my opinion.
Yeah. Well, because it doesn't follow the, Newtonian laws of physics?
The basic laws of physics.
Yeah.
Because there's tons of animals, for example, we'll talk about, that break the laws of physics. So they rewrite the laws of physics around the animal.
Like the
Pistol shrimp, mantis shrimp are the best examples.
Now, I was going to say the quantum entangled beetle that is in Japan, then it mysteriously shows up in North. I'm making this up.
It's phasing through reality.
Just
I'm not even
one
saying
beetle.
there's not an animal that's doing it.
It's figured it out.
I mean, if anybody's going to do it, it's water bears.
Yeah, water bears go from like atmosphere to underground. Yeah, I don't know. Sahara Desert. Huh?
I'm living on the sun.
That's right. I bet there are.
There are some that can survive that temperature.
I
for
would
a short
believe
period
it.
of time.
I would believe it.
No, so with this is the kind of that gateway drug from going from physics to quantum mechanics, the double slit experiment. If you take it how it is, and at some point you just gotta like, and that's what quantum mechanics, a lot of that does, is you just take it how it is. You gotta stop at some point because the universe is too big and too complexly designed to answer it for our brains.
Okay.
Humans can't even rationalize infinity.
No. Humans can't even wrap their mind around a simple magic trick of sleight of hand.
So with this, we know the universe, I don't know if it's conscious. Some of these physicists in the quantum mechanics believe that it's conscious in a different way.
Okay.
Because how does it know it's being watched?
Right.
Or is that us putting up these walls and we don't even realize it?
Right.
Nobody knows.
No.
Nobody will ever know.
No.
So what do you think so far about the double slit observer effect?
I mean, I've always had an interest in this for many years now, since I first heard about it or learned about it. I've also heard like things too where, I mean, it opens up the question: are we creating reality, or is reality, the world reacting just to us, or which like chicken and the egg?
I think it's all the same.
Which one came first?
I think it's all happening.
Yeah. Well, I mean, I think it's an important question too when it comes to like just faith in general.
Mm-hmm.
Are we? I think Earth is a special place, and I think we're special for Earth. Are we creating the world around us, or was the world created for us to create in? Which is kind of what I think.
I think yes, that's what I agree with too.
And I think that double slit experiment just shows the potential, like you can create.
Well, to me, I think I don't agree with that last statement.
Okay.
Personally, I think that it shows that the universe is so much more vastly complicated than we're even going to be allowed to understand. Mm-hmm. So the double slit experiment kind of gives you that little peek of saying, hey, you're never going to be able to move past this point into quantum physics because there's this curtain that's put up around you, purpose, whatever. So that double slit experiment is just the only way to kind of show that.
Yeah.
That, hey, there's more information than you will ever be privy to.
Right.
So when we start talking about angels, demons, parallel dimensions, and all this stuff, that we're not designed to handle that. Actually, we can say it. We can say that we understand infinity. We know it goes on forever. But they talk about that no human brain is can't anywhere near capable of actually comprehending what infinity means.
Right.
If you have a lot of people draw the universe, just tell people to draw the universe. They'll draw it like a disc because it's just like, well, that's the universe. It's like this. It's a plate, whatever. Because it's the best that our brains can come up with to rationalize forever.
Right, foreverness, yeah.
Whether you believe in the flat Earth or not the flat Earth, it's going to be an infinite.
It's more like a Pac-Man screen. Once you go off one end, you just come back through the other end.
There you go.
It's just that simple.
You're right. It's a lot, and it's like I said, it's a bad physics episode.
Oh, for sure, but I do. It's just important, like the nature of our reality. Like this is kind of. It just gives you a little glimpse at it, just a little bit. Like I don't know. I think everything is potential, and it takes a person, it takes someone to like want to will that potentialness into existence, And it's just everything. Like if you want to build your own bike at home, you can't just hope and pray that you're going to build it out of thin air. You got to actually put forth the effort and the will to make it happen. And I think this is just kind of a little example of you have to put forth the effort, the energy to put things into reality.
This is also used as evidence for the hollow universe theory or the hologram universe theory.
Oh, okay. Not hollow as in...
Like, no, hologram.
Right, hologram, not hollow as in like empty.
Yeah, no.
Okay, hollow.
That
H-O-L-O.
we're in a simulation.
Yes.
So I have some stuff about that. I just don't know. So despite how extreme this idea sounds, theories in this universe being an illusion or a hologram aren't new. Now researchers claim they have found evidence towards this hypothesis. A team of theoretical physicists from the University of Southampton believe they have found signs that the universe is an illusion by studying cosmic microwave background noise, CMB.
Heard of this before.
It's radiation left over from the Big Bang, supposedly.
Supposedly.
Yeah, supposedly. The holographic universe means that the information that makes up the perceived 3D reality is stored on 2D surfaces, including time. This means, essentially, everything you see and experience is an illusion, which the double-slit experiment is kind of peeking at that.
Right,
That this curtain exists, or more information, more data exists that you're not allowed to see. The second you stop watching the universe,
Yeah.
it does whatever it wants. It goes back to maybe even raw code.
Yeah.
What do we know? Like we can't see it.
One cool example that was explained to me kind of this is like you're playing in a video game and, you know, far off in the distance, you can't actually see what's...
Past render distance.
Past rendered, yeah. So once you're moving further along and what your eyes see is actually what's real in the reality. Almost like the tree in the forest, you know. If no one's around to hear it, does it make a noise? Which there's stuff around that's probably hearing it. But if there is no, like, just say example for a human around, does that tree even, I don't know, does it fall? Does it make a noise? I mean, does it even rendered into reality? I don't know. Until someone's there to witness it or see it or hear it, maybe it's not actually there, like physically.
So what they say, imagine that everything you see, feel, and hear is three-dimensional. Your perception of time, in fact, emanates a flat 2D dimensional field, says this professor, I can't even pronounce his name. The idea is similar to the ordinary hologram where a 3D image is encoded on a 2D surface, such as a hologram on a credit card. However, this time, the entire universe is encoded. Another way to simplify the 3D is 3D film. Although not an example of a hologram, 3D film creates the illusion of 3D objects on a flat 2D surface. The differences in the 3D universe is that you can touch objects, that the projection is real. Quote, you know, the projection is quote unquote real.
Physical.
For our perception.
Right.
Anybody outside the film knows it's just 2D and fake. Or not even fake. That's not the right wording. It's two-dimensional. It's encoded.
Yeah.
Well, theories of holographic universe have been around since the 1990s. The latest study, published in the Journal of Physics Review, contains the first quote-unquote proof, the researchers say. They find the evidence that the research developed models of holographic universe that can be tested by peering back in time as far as 13 billion years, at the furthest reaches of the observable universe. These models depend on the theory of quantum gravity and the theory that has changed the accepted version of classical gravity. So we've kind of talked about gravity before. When we and what you don't believe what the conventional definition of gravity. You believe that if you drop an object, it'll fall to the ground.
Correct.
Yes. So the holographic principles say gravity comes from thin, vibrating strings, which allow all the holograms of a flat 2D universe to exist.
Is that like that string theory?
Now, we're going to talk about string theory later.
Okay.
That's not string theory.
Okay, good. Okay.
Recent evidence in telescope and sensing equipment have allowed scientists to detect the vast amounts of data hidden, like it's almost white noise, of the microwaves left over from the moment of the universe's creation.
Okay.
So there's a lot of data, like, what is it? 98% of available data in the universe is imperceivable to us.
Okay.
So we're literally working at max with 2%,
Okay.
trying to figure all this out.
All this out, yeah.
So imagine if you're in a dark room, you get 2% of that room is illuminated.
And you have to guess what
You have to figure out everything else from 2% of a complete, like a ballroom.
Easy.
Yeah, sure.
Easy.
Using this information, the team was able to make comparisons between networks of featuring in data and quantum field theories, which once again, spooky action at a distance.
Yeah.
They found some of the simplest quantum field theories could explain nearly all cosmological observations of the early universe. This, they claim, moves quantum gravity along from being an alternative theory towards the more acceptable model. So this just came out like this year.
Okay.
Where their quantum gravity, this idea, which is a huge, vast thing we're not even going to get into, was always the back burner idea of what makes gravity.
Okay.
Now this type of experimentation is proving the accepted model of gravity should probably be put on the back burner for this thing.
Interesting.
Like I said, you believe that if you drop something on the ground, it will fall. Gravity exists. What is gravity is the question.
I guess, yeah.
Yes, it is true. We all had an agreement.
Well, it was explained best by Chris from our Patreon group.
And he said I'm a saint for trying to work with you. Yes. Yes, they said that. But no, so this, like I said, this is just moving that we don't know everything, and this experimentation is showing that the universe is much more complex than previously thought.
Right.
That gravity, these things, these observable, the end results are observed by us.
For sure.
What is causing them is still unknown.
Right. And it's, I don't know, it seems like a lot of modern scientists do their best to avoid anything of, they want to go back to the beginning. They tried to, the Big Bang and all this. They come up with all these theories and ideas. But the one thing that's like right in front of them is someone may have, some force, some ultimate power may have just created all these things. And to even try to make a connection to that, it's like they avoid it at all costs. Oh, no.
We'll talk about scientists and their one miracle. Well, that's coming up later.
Okay. Yeah, I mean, science relies on faith.
Science is a faith-based study. I don't care what anybody says. And
observable faith.
It's all explainable as long as they get their one miracle.
Yes. Ain't that funny?
I know. No, we're going to talk about that. We're going to take our ad break, and then we'll come back with some more stuff about this. But we're kind of going to end on this gravity thing. I can't explain it anymore to anybody at home.
What's that? The double slit
the
or
quantum gravity?
Okay,
the double slit. Anything after this is just guest talking, and it still is not a great explanation of any of these things. But we're going to bring this back to the cryptid and paranormal field because they are tied together.
Oh, for sure.
100%.
100%.
You have anything to add about these things? So the gravity, this gravity this quantum gravity is like, the best I can describe it is strings. So the string, like you talk about, why can you jump and not have as much tension versus, these jets trying to leave the atmosphere, these, spaceships trying to leave the atmosphere or fighting this giant string, this force of gravity. My understanding of the quantum gravitational theory is that imagine everything is connected by strings. The more, it's kind of tied to mass a little bit, but not really. Like the planet Earth has strings to us.
Okay.
So if you just gently pull a string, there's a little tension, a little bit of recoil. Not that bad, right?
But the further
and harder you yank on that string, the harder and it's going to pull back, and the recoil is going to be worse.
Like a rubber band.
Even steel cables. You look at the jets that launch back. When they come back, they'll cut through a person.
Oh, easily.
So that's kind of the most watered down version I can give of that theory to my best understanding.
Okay. If anyone else can give a better one, please. Right.
They're 100%. And that's not accurate.
Right to the show.
You know what I mean? That's not that's as accurate as I could make it.
Yeah.
They're talking about things that even the high level physicists are having trouble dealing with.
Right. Oh, yeah.
So that is the watered down. That is the milquetoast version.
Layman's terms. Yeah.
Yeah. All right. You ready for an ad break?
Yep. Welcome to the latest episode of Cooking with J-Clone77. And today I'm joined by a special guest, the Veggie Man. Say hello, Veggie Man. So you've got a special treat for us today. You're going to be cooking a new veggie dish, a vegan dish for us today. And what do you got on the menu? Ooh, artichoke asparagus spread, eh? I don't particularly like this, but I'm going to go on a limb and give it a try. Oh my goodness. It's delicious. What's the secret ingredient? Flavors of the forest Bigfoot breath? Raw garlic dust? Wow. They freeze dry the highest quality of ingredients raw to capture the flavor you won't find in stores? Wow. Thank you, Veggie Man. I'm going to add this to my kitchen. That's Bigfoot, Brad. By Flavors of the Forest. You can get yours at flavorsforest.com, and you can cook /corn. Sorry, flavorsforest.com /corn, and you can cook just like the Veggie Man.
And we're back. Man, the Veggie Man would understand quantum physics.
I think he's an interdimensional quantum being. He's quantumly entangled with spooky action.
You don't even know. You don't even understand what you just said and how right it is.
Oh, I know.
No, so
my brain is quantumly entangled with Einstein's at some point.
I'm going to read things to you here in a minute that I have no understanding of.
Oh, okay. You read it, I'll explain it.
Yeah, I have the definitions of these things, and it's just crazy. So, moving on, we've talked about the double-slit experiment with the observer effect, how physicists cannot agree on what is the right answer for that model.
Right.
And how either side of it is still insane as far as how we perceive the universe and how the universe perceives us. Mm-hmm. Isn't that a crazy statement?
Oh, very much so.
The universe, whether it's, conscious, some of them might say, in some way, shape, or form, and it's reacting to us versus anything else.
Or is it a collective conscious that we're all reacting to each other? Mm-hmm. It's a big dance where all arms are interweaved and tangled together, and we're just dancing on this plane of existence.
So one of the big questions, or one of the big things, is that we're made of atoms, right?
Yes. What's that called? When you're an atomist, what's it called?
Do you believe in atoms or not?
Do you believe like the physical reality of our existence is all building blocks is built up on atoms?
And that's not even the smallest thing anymore.
Yeah. So it's changed since then, yeah.
But atoms, particles, whatever you want to say, we're built of particles. There's technically more space in between our being, as in when you look at atoms, you look at these particles, you look at these building blocks. There's more space in between them than there's not.
Right.
So we should be able to put, and this is like a big question in college physics class.
Right.
Because you're going to get to that point, and why can't we put our hand through the table? When you slap the table, why does it hit? Like, technically, there's more space in the table, and there's more space in your hand, and there's not. Mm-hmm. There should be a way to technically phase through it. All right. I'm going to read you the answer.
Okay.
And we'll just read it, and we're going to go from there. If you try to put your hand through the table, you'll feel the force stopping you from doing it. But what is this force? It is the four fundamental forces in the universe that everything can be attributed to them. In this case, there's no exception. This is straight out of a physics textbook. The force is gravity, electromagnetism, the strong force, and the weak force.
Okay.
Clearly, gravity isn't the force in question. Firstly, gravity only ever affects attractiveness. Second, gravity is the very, very weak and only comes into play when you consider celestial-sized bodies.
Right.
The strong and weak force are only ever occurring on the atomic scale and are very rarely encountered in our day-to-day life. Leaving the force that's prevailing at the hand of the table is electromagnetism. As you will know, everything around us is made of atoms. Atoms are made up of small nuclei, which in turn are made up of positive and charged protons and electrically neutral neutrons. And tiny negative charges, electrons orbit around them. Isn't that a lot?
That's a lot going on.
This is just like out of a textbook. Literally, I found this in a textbook because, it had on the side, where sometimes they have little footnotes and stuff like that. Why can't you put the hand to the table? One of the things. A professor, whoever made the textbook, got tired of answering that question. He's like, it's on page 189.
Right. Read the syllabus.
Now, when you try to get close to the table, the electrons orbiting the atoms in your hand come into very close proximity to the electrons orbiting the atoms in the table. You can bring your hand very close to the table until you think you're touching it. In fact, you aren't actually in contact with the table whatsoever. The electrons in your hand are being repelled by the electrons in the table, creating a very strong repulsive force. You've heard that before in some dates.
Oh, for sure. They've called me the repulsive force.
When you think of the hardness of the table, it can quite strange, and you can't even get close to it. You can't put your hand through the table because the strong electromagnetic force is causing the electrons in your hand and table to repel each other. You can't even really get truly close to it.
Well, that makes sense that why you couldn't go just through it, like from chance.
But you don't ever actually feel anything.
Touch it, yeah.
You don't feel anything.
You feel the force.
Nothing
the
in this
force.
explanation, nothing in the universe is touching each other.
Right. It's like trees in the canopy. You ever seen an overshot?
Some trees do that, not all trees.
For the most part, though.
No, that is the odd.
What do you mean?
Where all the trees aren't touching, they leave a little gap.
Yeah.
Most of the time, they're competing and actively trying to murder each other.
Yeah, well.
And that, I think that's Pando is where that is. Because it's all one organism. When all the trees are actually connected to the ground. Mm-hmm. So overlapping them would do no good.
Right. I don't know. I thought that was more of just a thing.
No.
There's like space, kind of just space.
Go into any woods. You don't see it.
You got to look from above the woods.
No, that's a
down.
picture from underneath.
No, I'm talking about looking from above, looking down. You see the effect.
No.
Or whatever. Whatever. Flint.
I just think it's funny you bought into big science propaganda.
I've seen it. It was a natural observer.
Mm-hmm. So yeah, I don't know. This is just one of those things that I thought when we got to the weird physics episode.
Oh yeah.
That was something to include.
Mm-hmm.
Very short. Can't explain it. It's just what they say. It's electromagnetism.
You ever seen the movie The Men Who Stare at Goats?
Yes.
And it was like a kind of an MK Ultra disclosure thing. But they did that experiment where basically they were trying to phase through walls and things like that. And there's that one scene where he just gets up and he runs headfirst into the wall and knocks himself out. Mm-hmm. But it didn't work. But supposedly they had people that, I don't know if they could go completely through walls, but at least stick their hands through walls. But I don't know if it was ever recorded or observed. I don't think it could be. I'd imagine it couldn't be if, I don't know. I don't know how this would work. You ever seen the movie Mystery Men with Ben Stiller? They all have like superpowers. Mm-hmm. The guy from Shameless, William H. Macy.
I have, yeah, actually.
So the one, remember Kel from Good Burger?
Yeah.
So he was the invisible boy in that.
But you had to not be looking at him?
Yeah, nobody could look at him. And that was the only way, but he actually could go invisible.
So he was the double-slit experiment.
Basically, yeah. Mm-hmm. As long as they were watching him, he couldn't go invisible. But that one scene where he had to go sneak past the cameras, none of them watched him, and he snuck past all the cameras.
So, in physics, like we've already talked about in this episode, I guess another thing I'm saying about this episode is that a lot of either celebrity scientists or non-scientist people that bring quote-unquote science to people's attention act like everything is solved. Real physicists...
Bill Nye would be a perfect example of that.
Bill Nye's a good celebrity scientist, quote-unquote.
Who is not a scientist at all. I think he was a mechanical engineer.
Which is... that is a scientist.
I guess so, but not
a quantum physicist.
Not the stuff that he preaches and portrays, yes.
Yeah, anyways. So, I have 18 of the biggest unsolved mysteries of physics. We're just kind of going to go through. I have a little paragraph about each of them.
Okay.
Just saying that even though you hear these words out into the celebrity scientist community, physicists and quantum physicists do not know anything really about them.
Right.
They're just words. They're just things. They're ideas a lot of times.
Theories.
Yeah. Or things like we talk about with gravity, where we can see the end result, but have not explained to a satisfactory degree what is causing that to happen.
Right.
Does that make sense?
Oh, 100% makes sense.
First one, what is dark energy?
Made up.
Everything's made up.
Right.
No, so dark energy. No matter if you're an astroscientist crunches the numbers, the universe simply doesn't add up. Even though gravity is pulling inward on space-time, the fabric of the cosmos, it keeps expanding outward faster and faster.
So they say.
So that's the first, I believe in it personally.
Yeah.
But that's the first big contradiction. That if gravity is one of the prevailing forces of cosmic bodies.
Right. Why is everything going further and further
apart? Why we pulled towards our sun and why we're not pulled into our sun is centrifugal force.
Right.
But it's still pulling at us. There's that force there.
Yeah.
So why is the universe flying apart still?
Right, yeah.
This may explain it. What we don't know, like I said, there's a lot of questions when we get to this. It keeps expanding outward faster and faster. To account for this, astrophysicists have proposed the invisible agent that connects gravity by the pushing of space-time. It's called the dark energy. In most widely accepted models of dark energy, it is a cosmological construct that inherits properties of space itself. It is the best way to describe this to layman's terms. It's negative pressure.
Okay.
So like when you go up in the atmosphere, it's pulling out.
Right.
When you go down to the ocean, it's pushing in.
Mm-hmm.
So gravity would be the pushing in force, and this would be the pulling out force.
The dark matter.
Well, no, dark energy.
Dark energy.
Dark matter is something different. We'll talk about that. As space expands, more space is created, in which more dark energy is created. So this pushes space apart faster. So this can explain why the universe is expanding faster and faster. It's because as you make more space, you make the void. It's creating dark energy, which is pushing the void apart faster.
So, right. So in a sense, like when everything started at the beginning of time, it was just the void. And then God said, let there be light.
In my opinion, yeah.
And created where we live.
We're going to talk about universes and galaxies and how that doesn't make sense in conventional time scale and with other stuff.
Okay.
But all this is saying is this is a word. This is a construct in physics that they made up fully to explain the expansion of the universe.
Right.
That is it.
Yeah.
There is no real data to this. There's models produced. There's nothing really here.
So they're just doing
And some scientists, some physicists talk about it like that. They're very clear. Where in our models, this is a force that can be added to make the models make sense.
Okay.
And others talk about it like they have it in a bottle somewhere.
Right, yeah. No one has it. Yes.
I'm not saying it's not real.
Right.
It could very easily be real.
But it's not something
And some physicists, like I said, are very clear that like we make these models to kind of match what we see. Right? We can observe if you like the universe expanding to some degree. We can with how the galaxies and everything are spaced apart. We can kind of observe that. It doesn't make sense what we understand about physics. So we can add this thing, a property that makes it make sense.
Right.
So it's a proposed property that could exist. And some physicists talk about it like it's, like I said, in a bottle.
Speculative physics, perhaps?
All physics is speculative.
That's true.
There's tests you can do, and there's models. A lot of it's computer models now.
Which I don't trust. Yeah, computer models.
Good, bad, and different doesn't matter.
Yeah.
All it's saying is that, like I said, we are
It's the man
observing
behind the model.
the end result. And you can plug in different factors to make the end result make sense.
Right, yep.
It's like having a giant, massive math equation that you know nothing about, but you have the end number, or the end equation.
So you're still
just trying
solving for
to,
X.
You're just trying to put in pieces
That fit.
to make it make sense.
Right, yeah, makes
That's
sense.
it.
Yeah, it makes sense.
That's physics.
With conventional science.
Yeah.
Conventional understanding of our universe.
And I wouldn't even say that, because it's one group's opinion inside that big group.
Right, yeah.
Because physicists don't agree on a lot of this stuff.
Right, yeah.
So dark matter is my next one. That's another big question. So, evidently, about 84% of matter in the universe is not absorbed or not emitting light. So that's why it's called dark matter. It cannot be seen directly, and it has yet to be detected by indirect means.
So wouldn't that just kind of like be the ether?
Yes.
In a sense?
Yeah.
So
I personally, let me finish this little paragraph and then we'll talk about it.
Okay.
Where was I? Sorry. It hasn't been directed either. Instead, dark matter exists and its properties are inferred upon gravitational effects and on visible matter, radiation on structures in the universe. So we're seeing something in the universe that is hidden in our own solar system that has mass, that is not reflecting light and not emitting light. So it's absorbing everything. So, but we can see it reacting to visible things, or visible things reacting to it.
Okay.
The shadowy substance is thought to provide the outskirts of our galaxies, the outskirts of our solar systems. It's composed of wacky, intense, massive particles. Is literally the scientific name for it.
Wacky, intense,
wacky, interactive, massive particles.
Wacky, interactive,
WIMPs.
Just a weird.
Because the guy that first kind of proposed it, the best way he could describe it is this is wacky stuff.
Yeah.
So that is the name is wacky.
Interactive, minuscule. What was it?
They changed it modernly to weakly interactive massive particles.
Oh, yeah, because if you say wacky, then all their credibility is about to go out the window, and they can't have that perception.
A lot of scientists used to be fun.
Used to be. Now they got to follow the book and listen to I Am the Science.
So worldwide, several detectors are looking for these WIMPs, but so far, not one has been found.
I found one.
They're actually in the Arctic with bears, North Pole.
North Pole.
There are detectors built on these ice sheets. Mm-hmm. Several of them have claimed to detect these particles.
Yes, I think I've heard this before.
It's not been proven, confirmed by other people, whatever. They're very rare to be near normal matter, to be near interactive matter. So when we talking about like negative and positive forces and that kind of stuff, if the universe is basically a magnet, it's one end of the magnet, essentially. So it would make sense that they can interact with each other, but for them to become very close to normal matter or observable matter would also make sense in that form. Do you get what I'm saying?
Yeah, it does.
Okay. So yeah, detectors on planet, even the detectors themselves, it's very rare for one of these to crash into it because it's made of matter.
Right, yeah.
So how is it, yeah.
So how does it record it at all?
Like it's normally, they think it's like in these reactions in itself, every once in a while, one gets thrown so hard, one particle of this stuff gets thrown away so hard that it kind of ignores the magnet. So like you can force the negative and positive end of a magnet together.
Yeah.
It takes a tremendous amount of force. But they naturally don't want to do it.
Is that like what the CERN and the particle accelerators do?
We're going to talk about CERN too.
Okay.
This may be a little bit of a longer episode. I did not realize. But that's okay. Don't rub on the microphone, young man.
Did I?
Yes.
Oh, that was you.
You don't have headphones on, so you wouldn't know.
Nice try. Can fool the folks out there.
As you're being recorded on camera.
That'd be funny.
No, so yeah, that's pretty much it. That they don't know what these things are. I think that when we start talking about the ether and we talk about the veil and we talk about these entities being made of the other stuff, I think this may be the other stuff. It's matter that is not observable to our side of reality.
Right, yeah.
But it still exists. It has impacts on our side of reality, and our side of reality has impacts on them.
We just can't physically perceive it.
Yes. When we talking about literally, when we talk about shadow entities and that kind of thing, being dark matter, that they may be the only way our brain can ever show us there's a presence there is wrapping it in this void.
Like on Zelda Link to the Past, when you flip to the dark world, whatever, it's overlaid on the actual one. These are just entities from that world that somehow can interact, probably when we're in some sort of state of consciousness, like when you're about to fall asleep, or that you can physically perceive these things. I don't know.
So why is there an arrow of time is another big one in physics. Time moves forward because of the property of the universe called entropy, roughly defined as the layer of disorder only increasing. So there's no way to reverse the rise of entropy after it has occurred. The fact that entropy increases is a matter of logic. There is no more disorder arrangements of particles in their order of arrangements. So things change. They tend to fall into disarray. But the underlying question here is, why is entropy so low in the past? Put differently, why is the universe so ordered at its beginning when the huge amount of energy is crammed into what appears to be a small point in space?
Makes you wonder, huh?
Literally, it's a question in physics that breaks a lot of the other things. That's why a lot of scientists and physicists, normal physics professors, hate quantum physics because they do not agree.
Right.
Both high levels of science, that the one literally breaks apart the other.
Right, yeah. Well, that's so weird. It's just posing that
Einstein
question.
talked about it a lot, that physics is how we can interact with things, and quantum physics may be how things actually work.
Yeah. I just like that question. You know, it's so odd. It just seems to be everything at its origin was made with order and like a plan, and it just was created that way. That's so weird. Wonder what it is. Must be spooky action.
I'm going to skip some of these. So you mentioned string theory earlier. So is string theory correct? When physicists assume
it's wrong. It's a lot. There's.
Do you even know what it really is?
Yes.
Tell me.
No,
then you tell me.
To a certain extent, yes, I do.
Then
but
tell me.
Everything's interconnected in a way and running off like a certain vibration, and when you vibrate those strings, it affects strings in quotes, but it kind of ripples throughout everything else. So everything's like interconnected in a way. Everything's one. And then but the only problem is going back to its origin. The origin, the string theory, kind of collapses the theory in on itself. It's like what you talked about at the beginning, needing that miracle. That's how string theory operates as well. So I think it's a creative, well thought out idea that you can test, but I think at the end of the day, it's got its flaws as well.
Okay, I'm gonna read it and we'll see how close you got.
See how close I got.
When physicists assume that all the elemental particles are actually one-dimensional loops or strings, each with a vibration at a different frequency, physics gets much easier. String theory allows physics to recoil the laws of governing particles, called quantum mechanics, which the laws of governing spacetime called general relativity, and to unify the four fundamental forces of nature into one singular framework. Mm-hmm. But the one problem is the string theory can only work in a universe with 10 or 11 dimensions. 3 large spiraling ones, 6 or 7 compacted spiraling ones, in one time dimension. That compelled spiraling dimensions, as well as the vibrating strings themselves, are about a billionth of a trillionth of a single size of an atom nucleus. There is no conceivable way to ever detect anything that small. There's no way to explain the vibration or the validation or the invalidation of string theory.
Well, maybe the invalidation part of it you could, but I don't know.
I don't think you could do either.
Yeah, I guess not. So it's just another theory that...
Just a theory.
Yeah, you can't... I just don't like how people will take that and basically make it the gospel and make everything fit within it. You know what I mean?
Yeah.
Which is the same with everything else that we're dealing with.
Parallel dimensions, real fast. Mm-hmm. That's a thing that quantum physics kind of like... There's some proof to it as far when we start talking about these experiments that there is a lot more to... There seems to be there's like data around us that's interacting with us that we can't really interact with in an understandable way.
Okay.
So like there's a film, a wall, a veil, depending on what you're looking at it, that there's something on the other side of it. So the best way is the big curtain, is that you can see the movement on the curtain. Like if somebody hits a curtain, you're going to hear it, and you may even feel the air movement from it. But you have no conceivable idea what's on the other side of that curtain.
Right, yeah.
Does that make sense?
Yeah.
That's the basic way when we start talking about physics, is that there seems to be something there pushing at us or, bouncing, whatever, the universe is reacting in their own way. Collapsed quantum wavelength functions, we're not even going to get into. That's another big mystery. The last one is order in the chaos.
Okay.
Is that, you start talking about 3, 6, 9, all these things. Physics can't exactly solve this set of equations that describe the behavior of fluids, from water to air and all the liquids to gases. In fact, there isn't it's not known whether a general solution of the so-called Navier-Stokes equation even exists, or if the solution, whether it describes fluid everywhere or contains inherently unknowable points called singularities. Now, it's not the same thing as a singularity event.
Right.
It's different. As a consequence, the nature of chaos is not well understood. Physicists and mathematical mechanics wonder, is it whether it merely is difficult to predict or inherently unpredictable? Does turbulence cascade mathematical description, or does it make sense that we're all trying to tackle it just with the right math?
Well, I think the simplest way to explain that, the answer to that is you can't have light without dark. You can't have, what'd you say in there?
So this is really talking about...
You need opposites. You need chaos. You can't have order without chaos. Without chaos, there's no order.
I think I don't know if you're missing... This is talking about like water into gas.
Yeah.
This is talking about inherently we cannot figure out that there does seem to be an order to the chaos, and there's no way to figure that out.
Right, yeah.
Michael Crichton's book Jurassic Park has the Fibonacci sequence, on it. But he goes
golden ratio.
He adds it to every chapter, and it's the chaos theory that from inside the chaos you cannot see the pattern. If you're outside, it all makes sense.
There's a greater pattern at hand.
If you look at every chapter in the original Jurassic Park, there is this like just a growing design, and it looks inherently chaotic until the very last chapter. It zooms out and you see the whole pattern, and it's it's symmetrical.
Right? Yeah.
There is a pattern.
Yeah, I believe the golden ratio is probably what you're referring to, where the physical depiction of that.
Black holes. I mean, it depends on how much you want to believe. I believe in them. I don't know what they are.
Right. That could be the chaos agent.
It's a lot of people think it's the Great Eater, but with black holes, like black hole theory, Stephen Hawking's thing got shredded and nobody ever talks about it. Mm-hmm. Like that immediately other physicists just ripped it apart and nobody ever talks about it.
Is it still talked about today? Like
it's reformed.
Yeah.
But nobody ever talked about that the original paper just got destroyed.
So when the collection of powers that be, put forth this idea and use Stephen Hawking as a vessel to put it out into the public because he's they made him a credible guy until we found out later he had some problems that, I even question if he was putting together all those theories, that's just me. That's what do you call me? That person who's nothing against everything. Contrarian. It's the contrarian within me that probably thinks, looking back, that Stephen Hawking may have just been a vessel to spread the science. Let's put it that way. The science.
So I think we only did like 6 of the 18. Maybe we'll come back. If you guys like this, we'll do it again. If not, we'll never talk about this again. But let's start talking about the paranormal and stuff. Before that, though, you mentioned galaxies, age of the universe, the Big Bang, and how there's inadequacies in the explanations to a lot of that,
right?
As far as physics is concerned. Mm-hmm. So, with this, they just discovered this year galaxies that break the mold of the conventional Big Bang theory.
They're evolving the theory then.
No,
they're going to.
Well, they may. This will be the group step. Wasn't.
Yeah.
Because they were like, the Big Bang theory does not make sense anymore.
Right.
Because
good.
They have galaxies. They have a way of aging galaxies that I cannot explain accurately to anybody.
Okay.
But there is a way to age a galaxy.
Okay.
From observing it.
Yeah.
We can't really see close-up galaxies.
Okay.
But we can see far-away galaxies much easier.
Which is crazy to me.
It's because you're inside it, right?
I guess.
If you're inside the arm of a galaxy, it's hard. You can...
Well, your own, yeah.
Yeah, that's what I'm saying. We have a couple that are like right on top of us, too.
Andromeda is the closest one. And you can see that with your eyes, like physical.
Yeah.
You don't need a telescope.
So it's very hard when they're like on top of us or beside us to get a good look at them.
Okay.
So that when they're further away, you can see the whole picture, essentially.
Yeah.
The whole thing fits into frame.
Right.
Anyways, they age these galaxies. So they have complex galaxies that are almost the exact age that they say the Big Bang happened.
Okay.
So that breaks the rules. Because they said it took X billion years for complex galaxies to form after the explosion of matter. Mm-hmm. So when they're talking about this is that either the start is wrong, that the Big Bang was able to produce complex galaxies right then and there, essentially.
Yeah.
We're talking about galactic timescales, right then and there, essentially. Or that the age of the universe is very different than people perceive.
Right.
The age to form complex galaxies is different than people think. So this group is not stating what is wrong. Mm-hmm. But they say that this proves something in how we look at these things is wrong.
Well, who do we turn to ask, discover the truth of that matter? The Pope. The Pope will tell you what's really going on.
I just seen somebody made a joke that
isn't it the Pope the one that came up with the Big Bang theory? If I'm not mistaken.
I have no idea. Look it up.
I think it was.
Look it up.
I think it was the Pope in the Vatican that came up with the Big Bang theory.
Well, I'm sure. Everybody knows I'm a Christian. I'm sure when God made the universe, it was a pretty big bang.
Right.
Snapping
Yeah.
into existence.
Exactly. Yeah.
I'm looking it up.
I don't know. The more we do this, and even before we even started this, I was a big believer in the Big Bang. It's just I believed the science back then for a lot of things. I questioned a lot, but that was one of the things I believed in. But the more and more, like, you start picking at it or questioning it.
It was not the Pope.
Okay.
It was a Catholic priest.
A Catholic priest, okay. In the Vatican, right? I thought it came out of the Vatican, but I could be incorrect there, but wouldn't Catholicism...
I mean, it was a Catholic priest.
Right, yeah. In the Vatican, that's Catholic...
I don't know if he discovered it when he was at the Vatican. I can't find this if this guy was at the Vatican.
Okay.
He's Belgium himself.
Okay. Yeah, I didn't know. I just know...
And he worked a lot with Einstein.
Is the Vatican...
His name is Georgius Lamartine.
Oh, I thought you were going to say Giorgio. Is the Vatican... is that all part of Catholicism?
Yeah.
Okay,
that's
100%.
the head.
That's just Catholics only, right?
Yeah.
Okay.
Yeah, it's not, believe most other Christian, whether you want to, so I'm non-denominational.
Okay. I don't know. I really don't know.
So, but even most other denominations in the Christian faith do not appreciate the Catholic Church or the Vatican itself.
Especially the Vatican.
And it's not like a lot of Catholic churches now have completely stopped listening to the Vatican. Mm-hmm. It's a big deal. Like our buddy, I won't name him on here, but our ice fishing buddy.
Yeah.
They're Catholic. They have nothing to do with the Vatican or the Pope.
No, I know plenty of Catholics have nothing to do with it.
So it's not Catholicism.
Yeah, but it's
the Vatican.
Right, yeah.
It's hard modern day to separate them, but they are separate.
No, I get it. It's like turtles and tortoises.
Not really. But so let's talk about all this to show you is that they make very big fancy words to describe things they don't really understand.
That seems to be a lot of modern science.
Well, even physics. I mean,
physics,
good physics will tell you that. Uh-huh. That, we're seeing an end result. So when we start talking about ghost, you have the end result. If you experienced a ghost or a haunting, and like I said, I don't believe ghosts are humans, souls or anything like that. I believe they exist. I've had a haunted, lived in a haunted house, all that stuff. But you can see that end result. And for some reason, nobody takes it as seriously as gravity. I guess because gravity is universally experienced.
Right.
And you go anywhere on this planet, the gravity for the pull may change. But if you drop a cup,
it will fall down. Yes.
Anywhere on this planet, even if you're at the bottom of the ocean, it will fall. If you're on the top of the mountain, it will fall.
Even when you're supposedly on the space station, you're floating around there, and they accidentally the strings come off of the blue screen that they're in front of. Even that has gravity.
Yes. Mm-hmm. No, so all this stuff is to show that, like, when we start talking about, like, dark matter and dark energies, that is interesting to me when we start talking about interdimensional things. Mm-hmm. We start talking about the shadow entities and that kind of stuff. Because I think there's bleed. I think there's that this membrane, whatever you want to call it, maybe less around. When we talk about the observer effect, what if that isn't, like, they've been testing it 200 years forever, and they've gotten different results. They don't agree on what it means. None of that. Mm-hmm. So what if the observer effect is the membrane lifting off the universe behaving however the heck it wants?
Right, yeah.
Or some other different set of rules.
Yeah, like the different dimensions are being, kind of bleeding through.
Which I believe that they're kind of stacked on top of each other.
Yeah.
We talked about even just the light spectrum here, which is not outside of our dimension. It is inside our fish box.
We just can't see it physically.
We just can't interact with it. We don't see it. But the things that reflect in that light wave are still here and very real. So where is the difference between that and the paranormal?
There is none. There is none. It's all one. It's all one thing in one place. And scientists and big TV physicists will do their best to explain it and claim that they're right. But at the end of the day, we don't know. We don't know nothing.
Nobody knows. I think good physicists don't admit that they're working with models and theories and thoughts. And that's what they're working with.
Yes, good physicists will admit that and tell you that. Bad ones are deceptive ones.
Even in the research for this episode, I found that a lot of the times.
Yeah.
Where, doesn't matter what university they're working for. It really mattered if they have a high-level social media.
100%.
And celebrity scientists are about the worst thing ever.
100%, yes.
And I don't care what field of science they're in. Everybody knows, like Neil deGrasse Tyson. You know, I don't care for him.
Same.
I think he's.
I don't care for his ideas and his thoughts and the way he treats people.
I don't care for the way he treats people. Some of his thoughts I agree with. Some of the ideas I agree with. But that doesn't really matter to me.
Yeah.
It's really that the belittling side of it, and the fact that everything he says is fact.
Yes.
And even when you look inside of physics and astrophysics and those kind of things, they don't agree with that. You know, they're constantly changing ideas. Science is like that. Science is supposed to change. Like with the gravity thing, like we talked about when they're kind of, a lot of them are starting to switch it from the conventional gravity understanding to the quantum gravity idea.
Right.
And that's fine.
Yeah, it's fine.
They're
Yeah.
evolving. They're adapting. They're changing with the ideas. They found evidence to suggest this over this. So we're okay with that. You know, we know that gravity is real, but what is it is what we're trying to look into, because that may be how you discover those. If you believe in the gravity engines, that may be how you discover those.
Right. Yeah.
If you believe Bob Lazar's the football-sized propulsion engine is enveloping in gravity, conventionally it doesn't make sense right this second. But if you understand how gravity actually works, like if it's the string thing, right?
Right.
If it's these strings held to an astral body, then you just got to figure out how to cut the string.
Sever it.
And then you're moving completely outside of gravity.
Or if it's just an electromagnetic charge and you can counteract
Turn that
it.
off.
Yeah. And just repel, you know?
Well, hopefully you guys enjoyed something out of this episode. What do you have to say to connect it with this?
I just think the world, as we already know, is a mysterious place that we don't fully have a grasp on how it works. So be wary of those who claim they do, but be wary of celebrity scientists that try to lure you into a path and the ones that try to make themselves sound smarter and are always on TV probably aren't the guys to be trusting. I don't know. Like you said, anyone that talks in absolutes and says this is how things are and this is why things are the way they are and they have no wiggle room for any other thoughts or ideas.
Because that's not science.
It's not science at all. It's dogma. It's propaganda that they're pushing onto you. Thoughts that only they subscribe to, that they're pushing onto you, and not leaving the window open for other ideas.
At all.
At all, yes, is a problem. But no, I think the double-slit experiment is just a little window into that the world's a pretty mysterious and misunderstood place, yet it is 100% full of potential, and you can only achieve that potential with the initial belief in yourself that you can achieve it. And don't be hindered by conventional science and conventional thought and people who tell you that you can't. Avoid that. Avoid that, because you can. The potential is there. The double-slit experiment proves it. Everything's just a wave. Everything's kinetic energy, potential energy. Sorry. You need to put it into kinetic energy.
I should have let you explain physics.
With your actions and your thoughts. You make the differences. You aren't bound by others' thoughts and limitations on yourself.
The shrimps prove it.
The shrimps prove it. Be like a mantis shrimp.
Or a pistol shrimp.
Or a pistol shrimp. Yes. I don't know.
I showed you that video, and we're literally over time. I showed you that video of that mantis shrimp literally punching through that guy's shoe and like putting a hole in his foot.
Yeah.
Isn't that crazy?
Yeah, it was bleeding out through the boot.
It would look like a bullet hole.
Yeah.
And he punched him through a boot. Yeah, no. I have been the great and powerful Mr. E.
And I've been JClone65.
We'll catch you next week. Hopefully you guys enjoyed this episode.
Bye.
Hey guys, thank you for listening to Cryptids the Corn podcast. Remember, the best way to support the show is share it with a friend. But if you are craving more of the J clones
And more from Mr. E.
there's always extra content on Patreon.
And our paid member space on cryptidsofthecorn.com.
We'll catch you next time with more exciting, fun, and informative information. Bye.